think we're going to get started here. So welcome to the user experience of game development tools. Thank you very much for coming. I really appreciate taking the time. I know it's early. Some of you may have gone out to the party last night, might be a little bit tired. But we're going to try to keep things exciting, and we're going to have some activities and stuff. So let's just dive right into it. So first things first, speaking of activities, I'm going to ask for two people to come up to the front here. I need two participants. I'm giving away free games, so the first two people who come up right now are going to get free games. One, quickly, two. Okay. There you go. Actually, you know what? I'm going to hold these back until the end. Just you can sit down. Actually, for now, what's your name? Miguel and Dario? Miguel and Dario. Nice to meet you guys. Actually, if you could sit in the front, that would be great. And I'll ask you guys to come up in a little while. Thanks. So Miguel and Dario, my name is David Lightbound. I'm the User Experience Director for the Technology Group at Ubisoft Montreal. And I have a bit of a Cologne connection. My great-great-grandfather was actually a stonemason who worked on the cathedral. What's nice about working with your hands and working with these sorts of simple tools is that you have a real direct connection to the stuff you're working on. You know, the hammer and chisel is very simple, and you can really focus on just creating the, in this case, the stone that you're working on. So having a direct connection to what you're working on is really interesting and very important. It's something that we don't really see very often in our tools these days. I'd like to talk to you a bit about another story, something a little bit different. This is Lucy Suckman. She used to work for this company, Xerox. And in the 1970s, Xerox had this amazing photocopier machine called the Xerox 9500. Now, this was the most technologically advanced photocopier that Xerox had ever made. It did all sorts of things that had never done before, like photocopying double-sided, stapling pages, organizing them, things that people had never seen. It was really, really very advanced for the time. The problem is that it wasn't selling very well. And Xerox was trying to figure out why. So they were getting feedback from their customers who were saying, it's not really easy to use, we don't understand it. And the Xerox guys, the executives thought, no, that's just not right. We need to do let's get Lucy Suckman to come in and we'll do some research. So what she did is she went through Xerox and she picked out two people from Xerox that she wanted to come and do the test with her. And so she brought them into this room and they set up a microphone and a camera and she gave them the task, photocopy this document double-sided. So they start. First hour passes. They can't figure it out. Punching buttons, trying to push things, doesn't work. The second hour passes. They're still trying to figure it out. Can't really figure out how to get this machine to work. Third hour, they pull out the manual, this big, thick thing, and start going through it. They still can't figure it out. Finally, just throw up their hands and they say, forget it, we can't figure it out. So Lucy brings this video to the executives at Xerox and says, look, these guys can't figure out your machine. It's too complicated. So the executives watch the video and they say, well, it's pretty easy. And these guys are just stupid. I mean, that's the problem, right? They're not smart enough to figure out how to use this machine. They're stupid, says Lucy Suckman. That's when she reveals that these are two of Xerox's most brilliantly gifted scientists who work at Xerox. The guy on the left is the inventor of artificial intelligence. And that drove Xerox to start focusing on trying to make their machines easier to use. That's where the big green photocopy button came from. Over time of studying their users, creating prototypes, and understanding how people want to work. So how does that relate to game development tools? Well, have you ever had a situation where you're working with a tool that was really difficult to use and it slowed you down? It made it really hard to work. And how much time and polish have you lost because the tools are difficult to use? Or have you been involved in a situation where you don't have the time to create the tools that could be easier to use because you want to get them out the door as soon as possible? Now, the thing is, the users of these content creation tools, they feel bad. They feel stupid. They feel like they should be smart enough to use the tools. They think it's their fault. And at the end of the day, it's actually not really anybody's fault. We're trying to get these things out the door as fast as they can, right? So we want to try to get these tools into the hands of the content creators as quickly as possible so that they can start creating their content for the game. Here's what's going on, basically. So we take the time to make these tools. We try to get them out the door as fast as possible. Goes into production, and as a result, because these tools are difficult to use, production might be slow. And when you get to the end of the project, you look at the tools and go, wow, how did we ship a game with this? This is crazy. We're going to rework the tool, and you start all over again. What if instead we took a bit more time at the beginning to make the tools a little bit better? What if we did the research to understand our users and try to create prototypes to try to make a tool that's more efficient, which then might be more efficient in production, which means creating assets will take less time, and there's less rework. It's hard to see from far because, you know, the idea of spending more time on tools seems really intimidating, but at the end, it could actually take less time. Now, for me, my previous job as an artistic TD, a graphics TD, you might call a technical director, some of my best days were days where I would leave the office and I would, you know, be in the elevator with an artist or a level designer, and they would say, hey, you know, that tool that you developed, that you took the time to design, really helped me work efficiently. I was able to really create some great stuff today, and they felt they could just work. You know, they weren't hindered. And some of my worst days are those when I walk by somebody's machine and I see them banging away at just the tiniest little thing to try to get it. You know, just take one step forward at the end of the day. And as a TD, I had certain tools that were available to me. You know, I could write some scripts, I could try to do some coaching, I could try to improve certain things, but I felt that there was something that I could do that was a little bit further, a little bit more. How could I try to make these people more productive on a more consistent basis? So I started doing some research, and I came upon this field that has never really been applied to game development tools, and that's the user experience. And I started reading books, and one book led to another book, and I just started absorbing all these books and thinking about my work and how it applied to that, and that led me to a conclusion, which is the message that I'd like to share with you today, which is that the games industry needs to make the user experience of tools a priority. And this is nothing new outside of the games industry. Apple, for example, when they got into the MP3 player market, this was their main competition. Creative Nomad. It was big and heavy. The buttons didn't make any sense. It was hard to use. It had this little tiny display. And they responded with something like this. Simple, straightforward, did exactly what you wanted. And now nobody can deny that Apple dominates the MP3 player market. Or take Google, for example. When they entered the search space, this was their main competition. There's buttons all over the place. There's like a MasterCard or a Visa logo at the bottom. Do I have to pay for this? How does this work? Where do I click? I don't know where to go. And they responded with this. It's simple. It just works. They took the time to make it simple. They invested the time in the tool, so to speak, at the beginning. And again, now nobody can deny that Google dominates the search space. So why do we need to do this? Well, this is Jim Brown. He actually gave a talk yesterday. Is he here? That would be really funny. Right. I apologize for putting your face up here. He gave a talk at GDC 2010 called Level Design in a Day. And I'm going to extrapolate a bit from what he was proposing, but basically what he's saying is something like this. If you have 200 developers and you save them 20 minutes a day, that's about 66 hours every day, or 320 hours per week, or 18,000 hours every year, or about 100 months a year. Now, in North America on the East Coast, if you consider salary and equipment and training and floor space and all that stuff, a figure that I've been given is about $10,000 per man month. It's about 7,500 euros approximately. That means that when 200 developers save 20 minutes per day, they save 100 man months or $1 million every year. And how do you want to spend that time and money, right? Do you want to use it to hit your milestones? Do you want to use it to go home at the end of the day, you know, at a decent time? Or do you want to take that time to invest in polishing your game and not just trying to get it out the door? So why is this happening? Well, to understand that, we have to look at, you know, a large part of user experience is psychology. And we have to look at this thing called the action sequence, or the action psychology. When you perform an action, you do sort of go through this cycle where you look at the situation, you think about what you're going to do, and then you act. And then you go back to look to see the results, and it starts over. So you go over and over again through this wheel. Let's take an example with, say, a carrot peeler. This is the OXO carrot peeler. It's a great, great carrot peeler. So first, you want to figure out how to use this carrot peeler. You look at it, and then you think about where you're going to pick it up. I'm going to hold it here. That looks like a nice rubbery grip. I'm going to hold it that way. And then you go ahead and use it. And then you start over at the beginning and go through this cycle. Now, as you get more experience with this carrot peeler, you spend less time looking and less time thinking and more time acting because you've figured out that interface. It's very simple. It works. It makes sense. Jeff Johnson, who's an industrial psychologist, he's written a bunch of great books. One of them, Designing with the Mind in Mind, talks about an experiment he did with a user. He sits down with a user and puts them in front of a very complicated user interface, a complicated tool. And he says to them, I'd like you to go ahead and try to do this action, try to do this task. So the user looks at the screen, they think about it a little bit, and then he turns to Jeff and he says, you know what, I'm in a hurry, so I'll do it the long way. What? That doesn't make any sense. What does he mean? Well, the user interface is so complicated. He can't think of a better way of doing it. He doesn't know an easier way to go about doing his task. He doesn't know how to take the time to try to figure out a better way of accomplishing his task. So he's going to do it the old, tired way that he's always done forever and ever. And how many 20 minutes a day do we lose for that kind of behavior? Now, Susan Weinschenk, another industrial psychologist in the same sort of field as Jeff previously, wrote this other book as well, 100 Things Every Designer Needs to Know About People. And she also talks about the load that the brain can process. A thinking load, in other words, where you calculate, you have to store numbers, you have to think about numbers and put them together. That's one of the heaviest things that you can process. After that, looking, when you have to, light comes into your eyeballs, you process that information, and you figure it out. And acting is, or a motor load is actually one of the lightest loads your brain can process. So adding a couple of extra clicks, no big deal. But having to think of some mental math is a really big deal. So when we have these tools that are really heavy on the look and heavy on the think, it's doubly bad because you're spending all this time looking and thinking, and your brain is having twice as hard of a time processing that information. Now imagine if we had a carrot peeler that required some looking or thinking to figure out what mode is it in. Do I have to turn it this way? What does that mean? I don't know. Or something that doesn't, why is there a bird? Oh no, it's a carrot peeler. Okay, I got it. That just took me a second because I had to kind of look at it and think about it. Now, it would be nice if all of our problems were as simple as carrot peelers. Unfortunately, this is what a lot of our UIs look like. Now imagine if your carrot peeler did this to you once in a while. It would probably get pretty frustrating. So Steve Krug wrote this great book, Don't Make Me Think, which is specifically just about this. It's about reducing the amount of time and the effort that we spend thinking when we look at our user interfaces. So what we want to do is reduce the look and reduce the think so that we can maximize the act. So how can we do this? We can do this by learning from the field of user experience. And user experience is both an art and a science. It's an art in the sense that it doesn't make all the decisions for you. You have to, with experience, you have to make certain calls. It doesn't remove the TD or anybody in development from the process of creating these tools. But there is also a science behind it. For any of you who are engineers who study computer science, you may have taken a class in HCI, Human-Computer Interaction, where people talk about studying how humans and computers interact. There's research that's been done. It's being done all the time about the optimal way that humans and computers interact with each other. And we're going to learn about a few of those techniques. So we're going to go through each of these with examples. So we're going to talk about visual language, natural mapping, feedback, excise, representation, and progressive disclosure. Let's talk quickly first about visual language. What is a visual language? Well, the games that we develop have a visual language. We talk to the game through the controller, and the game talks back to us through the UI, through the things that we see on the screen. And there's an interaction loop that happens that goes back and forth. And it's very important to have a consistent and predictable visual language that makes you feel comfortable, that you can interact with. And often our tools don't have that kind of consistent visual language. Let's think about how different elements of the visual language can help the user. For example, let's take this word, pin. Now, in the case of icons, if you associate this word with something like this versus something like this, it changes completely the context of what's going on. Or when we use the same icon for lots of different commands, it can have the opposite effect, where users don't really know, they don't know what to predict what's going to happen when they click on something, or they can't remember what it does. Now, there is a UNESCO standard in regards to color. I know color means different things in different societies, but in general, worldwide, there's a standard for different colors being accepted for different things. We use color as a visual language as well. A game like Mirror's Edge is famous for pushing this to the extremes, where they use very, very stark colors to represent different things. But imagine you're an accountant, and you're trying to find a negative cell in Excel without it being able to change to red. We've sort of taken this for granted because Microsoft has done the work to do sort of a consistent visual language whenever you see something red in the cell, you know it's negative. Or as a developer, how accustomed are we to color syntax? Imagine trying to write without color syntax. We've been using it for so long. You try to find a variable or something, or maybe even an unterminated string or that kind of thing without color syntax. It becomes really hard, but we've become so accustomed to it. But how are tools, when it comes to color, how consistent are they in regards to the proper implementation and the proper usage and establishing a consistent visual language? Finally, speaking of color, this statistic fluctuates a little bit depending upon where you are, but about 7% of men are colorblind. Now, that means that in Europe, if you take that number, it's about 25 million men. That's a pretty big statistic if you consider that we use color in our tools to represent different things. Also, last time I checked, I'm even looking at this room, there are a few men in the games industry. Now, how does that affect people? There are lots of different kinds of color blindness, but the most common would turn this kind of stoplight into something that looks more like this. It's pretty hard to distinguish which is which. Now, in North America, at least in Quebec and in neighboring provinces, some of the lights have these shapes, so that even if you're colorblind, you can still kind of tell which is which. Now, how does this apply to our tools? Well, if you're going to create a keyframing tool, let's say, and you're using colors to indicate different types of keys, well, somebody who's colorblind might see this like this. Now, imagine you've been working for hours and hours. You're trying to pick apart different keyframes. It's a lot harder to do it like this. Now, if we added some form or some shape or some icons to these keyframes, it makes it a little bit easier, but it has a second benefit as well. Not only can somebody who's colorblind have a much easier time working with this tool, but also you can sort of infer certain things right away. I have a pretty good feeling that that first one is probably a sound keyframe. The next one's probably a footstep keyframe. The next one after that is probably a light keyframe. So there are really lots of benefits to doing things like this, thinking about establishing a consistent visual language for your tools. Let's talk about natural mapping. Now, it's a classic NES game, Punch-Out. Now, those of you who played Punch-Out remember that the B button on the left would do a left punch. The A button on the right would do a right punch. Seems to be mapped well. It's when the natural mapping is when the control the way you manipulate the control is directly linked to how you manipulate stuff on the screen. Now, imagine you reverse those two things. That would get pretty frustrating, right? You press the B button to right punch, Mike Tyson winks his eye, you're going to do your uppercut, and then you press the wrong button and you die. You'd get really frustrated by that, right? But our tools do these things to us all the time. Why isn't the mapping of our tools natural as well? Shouldn't we be doing something more like this? There are lots of examples of this. Natural mapping, again, reduces the look, reduces the think, to try to help us to use our tools more consistently. Let's talk about feedback now. Another classic NES game, Mario Brothers. Now, when you walked over a fire flower in Mario Brothers, you change color, right? And you know there's a sound, there's some visual feedback, something changes on the screen, the game is telling you something, you can press the B button to fire fireballs. And then, over time, that goes away and you can't press B to fire fireballs anymore. Now, imagine you walked over the fire flower and nothing happened. And then suddenly you realized, hey, I can press B to fire fireballs, this is great, and then it stopped and you didn't know why. That would be really frustrating, wouldn't it? To give you an example, I'm going to ask my two participants to come up here just really quickly. I'm going to grab this microphone. It's just going to be for a second, and then I'm going to ask you guys to sit down again. Here, you go ahead and take this. Now, we've sort of become accustomed to this sort of human interaction back and forth, so I'm going to ask you, I think your microphone is on. Okay, so how are you? I'm going to ask you how you are, and you ask me how I am. Okay, how are you today?
I'm fine, thank you. What about you?
I'm very good, thank you. Now, could you pass the microphone to your friend? How are you today?
I'm fine. What about you? Some feedback would be nice.
Thank you very much. You can sit down. I'll ask you guys to come up again in a second. That's pretty awkward. Wasn't that really awkward? We're accustomed to that kind of back and forth human interaction, right? So how come when I do something in my tool, there's no progress bar? There's no wait cursor? I don't know what's happening. That's awkward too. Is there still interactions that we're having, whether they be with people or with machines? It's still an interaction. We have to make sure that that kind of interaction happens. There are studies that show that even just having a wait cursor or a progress bar, even if it's indeterminate, allows people to be more confident, more consistent, and allow the machine or allow the tool to take the time to do what it needs to do. But if it doesn't do anything, the perception is that something takes much longer and that it's much more frustrating. Let's talk about X size. X size is more about the motor load, but it's still important to consider. Going back to our classic NES example, here is the classic NES controller. Now, on the left pad of the controller, there's this D-pad. You can go up, down, left, right. Now, imagine that those buttons were separated, and you're in the middle of a boss fight, and the boss is firing a bullet at you, and you have to move your thumb all the way over to the other side, and you die because it's so far apart. That would be really frustrating. But think about the original Xbox controller. Some people didn't like that, and they wanted to buy a smaller one. They bought a Mad Catz controller. Finally, Microsoft released the S controller. People are really serious about their controllers. If this was the case, people would really hate this machine, or maybe even hate the controller at the very least. But we ask our users to click through this tab, scroll down there, go over here, open that window, move this over to the side. That's X size. We have to try to keep our controls near the content that we're manipulating. And I've seen tools that are on, for example, 2 screens, and there's a little tiny button over here in the object that's being manipulated, and the user's moving their mouse back and forth to work on this. How much time do you lose doing that? Let's talk about representation now. I'm going to ask you guys in a minute, actually right now, in fact, to come up. Actually, just one of you, so you first, and then I'll ask you after. So come on up. Thanks. I think you should pick up the microphone there. There you go. Okay, so what I'm going to do is I'm going to show you a series of letters and numbers on that screen. Okay? And I'd like you to try to remember as many of them as you can. I'm going to give you 5 seconds. Okay? Are you ready?
Yeah.
Go. Okay. Now, how many of them can you remember?
Do you want me to say them? Or?
Sure, yeah, just say them back.
K, I, B, G, M, L. I think there was another I at the end.
That's pretty good. That's pretty good. How many?
I'm kind of lost right now.
How many would you say there were on the screen approximately?
Around 10,
okay, around
13.
10. So I'm going to show the same letters and numbers to you again for 5 seconds. Are you ready?
Yeah.
And I want you to do the same thing, memorize them. Okay? Go. Thank you very much. Yeah. That's good. Thanks. I think I've made my point. Representation is organizing the data in such a way that it's easier to understand, easier to represent, easier to read. Even information architecture as well is another term that people will use. Now, now I have to ask you to both come up. Now we're going to play a game, okay, which is similar to representation. Now you can see how by structuring the information, we've made it easier to understand. So you guys are going to pass the mic back and forth. Here's how the game works. Okay, come on up. I think we have to squeeze in here. So here's how the game works, basically. So each of you are going to pick a number, one after the other. You're going to take turns, okay? And so what you want to do is you want to pick a number, you want to each pick a number, and then you want to have 3 numbers at the end that add up to 15. Okay? So you want to, even if you have picked 4 or 5, you want at least 3 of them to be 15. Does that make sense? So here's how it could work. One picks 6, the other one picks 8, one picks 4, the other one picks 3, one picks 2, the other one picks 9, and then the other guy picks 5, and he's got 3 numbers that add up to 15. Okay. Does that make sense?
Yep.
All right. So now we'll start over here. You go ahead. You want to pick one?
Okay, 5.
Okay.
Who's going to press?
Oh, no, you don't have to press it. It's
okay.
fine. Just leave it like that.
Okay. 5.
3.
6.
Okay.
7. 4.
I think you've got it. All right. So I think that totals up to 15, if I'm not mistaken. Yeah. Okay. So thank you very much. That's good. You guys can sit down. So you can see how that game, without being able to write it down on paper, it's really complicated, right? You have to keep these numbers in your head. He went straight to 3, which was really good. Sometimes it'll take people to 4 or 5 numbers before they, can get enough in their head to do 15. But even then, it takes a lot of mental calculation to try to figure this out. Okay, let's forget about this for just a second. You can see how this can be really heavy on the look and the think. You have to look, remember which ones you picked. You have to think and do this mental math. Let's play another game completely different from this one, okay? Tic-tac-toe. Nothing could be simpler, right? So you put an X, another guy puts an O, you put an X, you put an O, you put an X, you put an O, and you've gotten around your opponent and you've won the game. That's really simple. It's very visual. It doesn't require any sort of mental math. Well, what if I told you that these 2 games are actually exactly the same? This is something called a magic square, and this is a great example of representation. I can play tic-tac-toe on this because all of the different angles add up to 15. It doesn't matter which 3 that I pick. So I can play my same tic-tac-toe game and not have to do all the mental math. I'm just doing this completely visually. That's a good example of representation. And we can do that with our tools as well. Now, finally, I'll talk about progressive disclosure. Here's a game, classic game, Counter-Strike. Now, when I'm playing Counter-Strike, I don't need to pick up weapons all the time, right? I just do it at the beginning. So then I can pull up my weapons screen. But otherwise, I'm playing like this. I have a very simple interface. I don't need to see more. I don't need to see everything at once. There's this great screenshot that somebody made. I don't know who to attribute it to, but this is actually a UI for a ridiculous UI for a first-person shooter. There's a little tiny space in the center there to play your game, but the rest is, you know, like you've got your ammo, your mana, who's shooting at you, messages, you know, your map, your rank, all this stuff all at once. This little tiny space, and just in case you forgot, it just reminds you of the game that you're playing here at the bottom. This is a bit of an extreme example of throwing everything in your face at the same time. I mean, you know, our tools would never do that. Oh yeah, it's our friend from before. Now, there's nothing wrong with trying to just present what the majority of users need and having an advanced button for something that is not used very often, something that more expert users want to use, or that they can open up and then keep that open just for them. That's progressive disclosure. And then finally, I'd like to just finish off with one of the most important points before we go on to a real-world game example, a game tools development example. Mental models versus conceptual models. Now, what is a mental model? Everyone has a mental model of objects that they manipulate in everyday life. A book, for example, I know, has a page or has pages with text on it, and I can flip from one page to the next. Now, what's the conceptual model of this? The conceptual model is how something actually functions. The conceptual model of this device is that it has buttons. It looks like it has a screen with some stuff on it. Now, to me, lots of things have buttons and screens. I mean, it could be a calculator for all I know, or it could be a computer. But as soon as you tell somebody that this is just like a book, they apply their mental model to the conceptual model. They try to match the two together. So they start looking for the next page and the previous page button. They start looking for that screen with the words on it. And the tools where the mental model and the conceptual model are very close are some of the best tools, easiest tools to learn, easiest tools to use. So that's a few ways that we can use to reduce the look and reduce the think to maximize the act. There are lots of different techniques that we can apply in user experience and usability to try to improve our tools. I don't have time to talk about all of them, but I'd be happy to talk to you about them afterwards if you're interested. So let's finish up with a real-world example. And let's talk about a depth of field tool, which is based on a personal experience. Now, let's say you're working in a development, and you know, an artist talks to an art director, who talks to a lead programmer, who talks to a graphics programmer, who talks to somebody else, and the word gets up the chain that somebody needs to be able to blur something and, you know, have a depth of field blur. So you want to have something focused in the middle and then have the rest blurring as you go out. So the word gets to the graphics programmer, and he says, great, no problem, I've got something called set DOF. Or you can set the distance from the camera to the focus point, and then you can set the start and end of the near blur and the start and end of the far blur. This is pretty common. So it's done, right? Well, if you're going to set your depth of field once for your whole game, don't create a tool. It's fine. I understand. Let's not go too far here. If you're creating an isometric game like Diablo or whatever, you don't need to set your depth of field all the time. But in the case of first-person shooters or other games where your camera is a little bit lower, you have to set the depth of field all the time. When you're focusing on an object, in the case of Assassin's Creed, let's say. Or when you're changing weapons, your melee weapon can't have the same depth of field as, say, a sniper rifle. And of course, the big one is cutscenes, right? You're changing depth of field all the time in your cutscenes. How do you take care of that? You need to give the content creators something to manipulate the depth of field themselves. And you could ask them, well, why don't you just go ahead and type this stuff into a script, and then they write DOF lowercase, or they forget a semicolon or a comma. So that's not really a good solution. And the thing is, when we create a tool, sometimes we actually create this. But the thing is, this isn't really a tool, and it has a couple of issues. First of all, we talked about natural mapping and representation. The near start and near end and far start and far end are separated because that's how it was in the command. It's just being naturally mapped to it's just being mapped directly to the tool. There's a lot of XIs where I have to click up and then apply, click up and apply, click up and apply. But the worst part of it is that this is just a direct exposing of the conceptual model. We're just exposing that set DOF command. Maybe we can't put a semicolon by accident or not, or do a lowercase, but it's really not all that different from what we had before. So you can see how both of these solutions aren't really helping us to make the user experience better. They still have their issues. They're still heavy on the look and still heavy on the think. Now, typically, here's what happens in a development. There's a feature request, like we spoke about. Somebody said, hey, I need depth of field. Somebody writes some code. This doesn't always happen, but this could happen in a lot of different situations. Somebody writes some code, and then they put an interface on top of it, right, to expose it to people. The problem is that often, if you even have time to go back and fix it, often the artists will say, or the content creators will say, this isn't quite what I was looking for. I don't understand how it works. This is not very efficient. You have to go back to the beginning. So why go through this whole process if you're just going to start back at the beginning? We have to get rid of this idea of thinking about things in terms of a feature request and think more about user goals. This is a really important concept. Alan Cooper is a very outspoken but also a very well-respected name in the field of user experience. And he wrote this book, The Inmates Are Running the Asylum. And in his book, he uses an analogy to describe programmers who are developing tools. Now, programmers who develop tools are a little bit like extreme sports enthusiasts, right? Let's say, for example, somebody who does moguls. If you're a really, really good and talented athlete, you're going to look for the most difficult, the most challenging, the smallest, the tightest moguls that you can possibly find, right? Because you want the biggest challenge. Developers are accustomed to having really big challenges. You have to be at the top of your game to be a really good programmer, right? You have to know all the latest stuff. You have to work really hard. It's something that's not easy, but a lot of developers, and myself included, you really love that challenge, right? You love that challenge of being able to figure something out. When you figure out that bug that was really obscure, you feel really good, right? And that's great if you're writing code, but maybe not so great if you're creating a user interface. If, for you, it's okay that there's this really complex tool that takes a lot of time to learn, but there's a really big payoff, that's great if you're using it all day. But if there's somebody who's picking up something once in a while and they don't really understand how it works, well, it might be better to have somebody who's able to analyze the users, watch them work, and figure out their goals to design that user interface, and work with you to develop that tool. And there are a lot of developers that I've met who really don't really enjoy working on user interfaces anyway, so they would like to have somebody who works on that side of things. Now, to describe this concept, I'm going to ask my participants to come up again, and we're going to talk about, you each take a piece of paper here. You get one, another. We're going to talk about Swiss Army knife versus scissors, okay? Now, Swiss Army knife, really cool, right? It's got all sorts of blades and corkscrew and all sorts of stuff. I can't really see what it does right away, but it's pretty flexible, so I'll give that to you. Just hold on to that for a second. And scissors, they do one thing, but really well. You understand how to use them. I'll give this to you. Don't fold your piece of paper. I'm going to ask you guys one at a time. You're going to go first. I'd like you to cut the piece of paper in half, right down the middle, okay, without folding. Yeah. Go ahead. All right. Very nice. That's a very, very good job. Very clean. Thank you. All right, that's great. Okay, now, thank you. I'll take those scissors. You can sit down if you'd like to. Now, I'd like you to do the same. So go ahead and take out the scissors. And I know they're a little bit smaller, but hold on. I'll hold this for you. Are you there's some blades at least.
There are some blades, but
okay.
no scissors in this one.
Oh, you know, with the scissors, they broke yesterday. That's true. Yeah, I forgot. We haven't had time to fix it. You can use a knife, though. That's the same thing, right? I mean, just be careful of your fingers. Don't pull it out too much. Hey? You could probably hurt yourself. Okay, so go ahead and pull out that knife there. Okay, you go ahead and try to cut this in half. Without folding, yeah. I think you should be okay. Yeah, that's the best technique I've seen. That's pretty good. Oh, yeah, that's the paper crashed. That's all right. Oh, not bad. All right. Thank you very much. All right, let's give these guys a round of applause. Thank you. I'm going to ask you to come up again in just a minute, but thanks for that. That was perfect. A very good representation. First of all, I don't know what to do, where it starts. I might hurt myself. It does a lot of really cool stuff, but it doesn't do what I am trying to accomplish. It doesn't accomplish my goal, which is to cut the piece of paper in half. So that's the difference between a feature request and a user goal. It's also important to think about who your users are. So, beginners want to know what the tool does. They have questions, how does it work, what does it do? Advanced users want to do scripting and customization and stuff, but in many cases, a vast majority of your users just want it to work. They just want that Xerox one-button solution. And in the case of some tools, not all of them, but in the case of some tools, you're going to have the majority of users are going to be intermediates. They start off as beginners, they learn how to use the tool, and they don't necessarily get to the point of being experts all the time where they want to do all this customization. They just want it to work. So your tool might have all sorts of cool customization stuff and dockable windows and hotkeys and stuff, but those intermediates that in some cases make up the majority of your users are never going to use those things, or very rarely. So you need to focus your development on what the user goals are and specifically what the majority of your users who are using the tool are going to do. And not only that, but think about the fact that you have these intermediates and beginners who are coming up to experts and asking questions all the time. How do I do this? How do I do that? If your tool was easier to use and focused on just the user's goals and made it very simple and easy for them to use them right away, how much more time could your experts gain to work on the really big problems? So the new process would be something like this. Start off with the user experience, or the user research, rather, of user experience. Understanding how the users work and watching them in their environment. Think about their user goals. Extrapolate from that observation what they're trying to accomplish. Design a mock-up of an interface. It could be, you could be using tools or it could be on paper. A mock-up of the interface to understand, to sit down with them and walk through the process to try to figure out if they even understand what's going on. This is a really cheap way of figuring out what works and what doesn't. If you start writing code right away and you have to go back and make changes, either you're going to have no time or it's going to be really expensive to make those changes. And then finally, implement the design. Now, to finish up, we're going to have one last example here. We're going to talk about our depth of field tool. I'm going to ask one of you to come up. Just one is fine. We're almost done. You're going to get your games after. So here's the deal, basically. I've created this depth of field tool. And what I want to do is to try to match what you talked about representation. We want to match the mental model of that tool. So when I think about depth of field, I want to look through the viewfinder of my camera to figure out what I'm going to focus on, or I want to adjust the ring to figure out what I'm focusing on. Because people are artists. They're going to work visually. They're filmmakers. They're cinematographers. They're painters. Content creators. So I'm going to have you try out this new tool in just a minute. Because if our camera, here's the image that we're trying to recreate, right? You remember from before. If our camera is here on the left, and this is the focus point we want to focus on, and we want to have the start and the end be over here, and the start and the end be over there, well, isn't this what our tool should look like? You can see how it matches the mental model, the representation. It's easier to use. It's easier to understand. This is a lot easier. Which one would you prefer between this one and that one? I'm pretty sure you prefer to use the one on the bottom. You can see how this one matches the mental model of the tool that we're using. You remember we talked about the mental model. This matches how the user thinks about depth of field. So here's where you come in. Now imagine that you're our content creator on the production floor. In comes the art director. He's going to come and ask you some questions about the depth of field. So first thing that he wants to know is, using the old tool, he wants to know which of these three examples, you're going to see three examples of depth of field, which of these three is the point where it's focused closest to the camera. Okay, you're going to have 5 seconds to do it because he's in a rush. This guy's in a real rush. Are you ready? And go.
The first one?
Okay. So you had to kind of bounce your eyes around the interface to try to figure out. Yeah, exactly. So let's try another one now. It's going to be the exact same thing. And go.
Yeah, it's
the first one again.
Yeah.
But it's a lot easier for you to understand. It's a lot faster. Okay, I'd like to get my... thank you very much. Get my other participant up as well. This one's going to be a little more challenging. Now it's your turn. The last one, I swear. Okay, this one's going to be a little more complex. Now, what we're doing in this case is the art director wants to know which of these shots, these three shots, has the most amount of blur, which has a lot of blur. So what you have to do, basically, you have the interface. You're going to see three examples of it. You have to take the last number and subtract the third number, and then take the fourth number and subtract the second number, and then add those together.
Perfect.
And you have 5 seconds. You ready?
Okay.
And go. So now I'll show you the same interface again with the same challenge with the new UI.
Yep.
And go.
It's the last one.
Exactly. So thank you very much. Okay, give you guys a hand once and for all. Thank you. So now you can see how using representation, using some of the techniques that we've used, reducing the X size, reducing the, trying to do natural mapping, et cetera, allows us to reduce the look and reduce the think so that we can maximize the act. So now you're starting to understand what I was talking about at the beginning when we talk about investing a bit more time in developing our tools. The fact is that at the end of the day, this is just one slider in a sea of buttons and radio buttons and checkboxes that make up the radio buttons and checkboxes and sliders in a screen in one of your tools that make up all those screens in that tool that are connected to all of the other tools that you have that are all intermixed together in all the different tools and engines that you're using. So you imagine saving a little bit of time like we did now across all of those things, and you start to understand why when 200 game developers save 20 minutes a day, that they can save 100 man months or $1 million every year. So what can you do about this? Well, focus on trying to reduce the look and reduce the think to maximize the act. Sit down with your users, watch them work, understand who are the intermediates, who are the beginners, who are the experts, understand who the majority of your users are on a tool-by-tool basis. Sit down and observe them at their desk in their environment working. See what their goals are. Ask them what they're trying to accomplish, not what features they want. What are they trying to accomplish? Understand what their goals are. Not just trying to make a feature, not just trying to make a Swiss Army knife that does everything, albeit not so well, but one thing really well. And try to apply these different techniques that I spoke about, you know, the establishing a visual language, representation, feedback, et cetera, and create some mock-ups and present them to the users and try to get some feedback before you write a single line of code. There are lots of books out there that you can read. I'm going to show this link again at the end. But there are a ton of books out there that give you a lot of really great ideas. A lot of the techniques that I use and some of the stuff I presented today comes from these books. And share your ideas with your team. We do user experience workshops at Ubisoft in Montreal and worldwide, actually, where I will go around and host a workshop to show people these tools and techniques that they can use to try to improve the user experience of their tools. And so now, again, you can see that by investing a little bit of time in the beginning, well, maybe we can do a little bit of this at the end, maybe a bit more. But at the end of the day, all this stuff around is really not that important. You know what we really want to happen? We want this to happen. We want the user interface to fade away. We want it to become so natural for the user that they just focus on their content. They focus on what they're creating. They focus on making the best kind of games that they can. And they don't think about the tools. They have a direct connection to their work, and that they can make the best work of their careers. And that's why I think that the games industry needs to make the user experience of tools a priority. Thank you very much. So just one quick note. Myself and a bunch of other guys who work in the industry, and Mike Acton included, very passionate about usability and user experience in games development. We did a Google Hangout. If you go onto Google and type in usability Hangout, you'll see myself and a bunch of other guys from Blizzard and from a bunch of other game development studios, all talking about the importance of usability and user experience in game development tools. So just go ahead and Google and type in usability Hangout. We're planning on doing more of them in the future. So I'd be happy to go ahead and answer your questions en anglais ou en français. At the bottom, I have that link that I spoke about before. So I'd like to open up the floor. There's a microphone here, and I believe there's another one in the back somewhere. Often the question that I get is, this costs a lot of money. How do you do that? Seems to be the first one. Anyone? So you all know how to do that. All right, let's go. Let's do it. Yes. I think you want to grab this mic, or?
So my question is, all this stuff you said basically applies to a workplace where you have some tools already in place and you want to develop some more tools for artists who can already basically do what they want, but not the way you want them to. So my question is, what do you do if you have if you are developing a tool that is not finished yet and that does not that does not have an equivalent that you can just go out and say, well, do this, and then I watch you do it, and then I can think about how to do it better. So in this case, you would have to program something first in order for them to do something.
Yeah. Oh, okay, so well, there's two parts to that question, and I'll I'll repeat it back to you just so I understand and make sure that I understand it. So you've developed a tool already part of the way, or maybe even you have developer resources that are waiting for a design or waiting to understand what people need, but they want to start working on stuff, right? Or you've already half done something. If you have already developed something, you can sort of do a calculation to try to figure out how much time you're going to lose with a tool that's not really made to be optimal. You know, the amount of time that you take to spend rewriting that actually might be a lot less than the time you're going to lose in development when there's 200 people or there's even 20 people working on it, first of all. And second of all, I think it does happen often, and this is sort of how we do it in terms of sprints, is I'll work with the developers one sprint ahead of them, so I'll do the research and the design, and as they start their sprint, then right before I'll deliver the designs to them to say, here's the research I did, here's the user interface mock-up that has been shown to the users, has been approved by them. They save lots of time. They start working right away with the design instead of, you know, trying stuff out. And so before that time, though, the developers say, well, what do we do? You know, we don't have anything. There's always a lot of back-end work that you can do. There's always a lot of preparation work. You know, the UI usually is not necessarily a huge part of that. You know, you're executing some code underneath that doesn't require any user interface. So what I'll typically do is they'll start off by doing some of the back-end or the stuff that's under the surface. And then when they start their next sprint, then they have a UI design that they can work with. Does that answer your question?
Yes, it does. Thank you very much.
Thank you. Anyone else? Yes.
One thing, how much influence or how much are the users of the tools in the end integrated into the development process at your place? One thing that we try is basically once the thing is somewhat usable, we bring them in and say, this is what we have, look at it, play around and tell me how you like it. Yeah,
I mean, they should be. There's an analogy. I'm trying to think if I should. Yes. So one of the things that I talk about in my workshop is that this sort of high overarching quote from that the first day of the workshop is that developers aren't users and users aren't developers. Okay. So the developers aren't users means go out and watch how people work. But users aren't developers also means it's not the users that are going to design the UI, if you can afford that, right? Having somebody who sits between the two, in my case a TD, who works with the two, because it's not a user's job to design a user interface. And it's not necessarily the best use of a developer's skill set to design a user interface either, okay? But they should be involved in that process the whole way. So figuring out where to place the buttons and stuff, it's not really a user's job, but being there to look at the tool and to iterate on it, absolutely, they should be involved all the time. Now, once in a while, you're going to move a button 1 pixel to the left, go ahead and do that yourself, right? There are limits to how much you can do, obviously. But when it comes to sort of like the big push at the beginning, take the time, it's going to pay off. Take the time at the beginning to really sit down with them and then meet with them again, like you're suggesting, and you know, get feedback from them, because you know, every minute or every hour that you spend at the beginning of the process, I believe, will pay off in efficiency at the end. Does that answer your question?
I think so.
Okay. Yes.
So how do you make sure that artists always have the latest tools and don't actually use the old versions and stuff like that? What's the best way to do that?
Well, it's interesting, you know, because we can apply certain elements of visual language to that. One of the things that that we had at a previous studio that I worked at was, you know, like when you'd launch up the tools, there would be a bar, like a red bar or something that would say, hey, you know, you don't have the latest version, and better yet, click here to upgrade to it, you know. So there's no question about where to go or what to do. And if they have the latest version, well, it's just gray or blue or just everything is okay or whatever. Typically at the startup of the tools, or even if the tool stays open, you can check every once in a while what's the latest version, and even better, you know, provide a link or something, a button to go directly to install the latest version of the tool. I found that's what worked really well. That was a really good system. Anyone else? Is anybody else doing something like this at their studio? Anybody, taking the time to design, focusing on designing the tools? There's my friend, great. There was a question back there, yes.
So we have a lot of tools that are actually usability nightmares, but we've been using them for like years.
And by the way, just to quickly mention, this is very common in the industry, so don't feel bad. I mean, everybody has this problem.
I don't. But the thing is that people learned how to use them and are fast in using them. Do you think it makes sense in improving the user interface with the price of having them learn everything from scratch?
Sorry, I didn't understand the last part.
So if we improve the user interface, then they'll have to start learning again the tool that right now they know how to use.
Okay, I understand. So the question is, this is a very typical question. The question is, if you change the tool, then they're going to have to relearn the user interface, and they might be upset about that. This kind of thing happens all the time, right? I mean, big companies like Autodesk and Adobe are scared to death of changing their UIs because the users are going to rebel or push back against it or whatever. I think if you're able to do the calculation like I showed you before, I have a little spreadsheet that I use in my workshop, which is, you take the number of people times their salary times blah, 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 blah. So if you can figure out that it's going to take somebody a day to learn a new UI, but it's going to save them 100 days worth of time, well, I think the calculation is pretty simple. And I know it's intimidating. I know it's frustrating to do, and I know you know that you're going to have to deal with lots of questions and lots of, hey, why did this change? I think also, being able to communicate how it's better or why it's better. And that's where also doing research is really important, because you can pull that stuff out and say, look, when we spoke, you said that you just want to build all the time. That's the most important thing you want to do. So we put a big green build button at the top. So it's easy to click, or we put it on easy hotkey or whatever. That's why we did this, because we did this research, and 9 out of 10 people want to build, really easily all the time. So I think doing the research and then being able to use that to communicate your intentions for changing the design is important. I know it can be intimidating, but I think if you do the math in the long term, I think it'll pay off. Does that answer your question? Great. Anyone else? All right. Last chance. My email is there, and I'm going to be here for a little while if you guys have any questions. So other than that, thank you very much for coming, and I hope to speak to you later.